revolve in horizontal circle of radius 4 meters with angular speed of 2 radians per second. With what tangential velocity will the stone move off the circle of the string cut? Solution. Tangential velocity equals to angular velocity times radius of the circle r. Tangential velocity v equals to angular velocity omega times radius r, which is equals to 2 times 4, which gives us 8 meters per second. Question 3. A particle of mass 2.5 times 10 raised to power minus 6 kg revolving around the earth has a radius acceleration of 4 times 10 raised to power 7 meters per second squared. What is the centripetal force of the particle? B. A simple pendulum makes 50 oscillations in 1 minute. What is its period of oscillation? Solution. Centripetal force is equals to mv squared over r, where v squared over r is the centripetal acceleration, which is given, and mass is also given. Then, putting in these values, the missing values, we now have force, which is equal to mass, which is 2.5 times 10 raised to power minus 6 times, which is the centripetal acceleration, which is v squared over r, which is 4 times 10 raised to power 7 Newton. The force is now equal to, a centripetal force is equal to 2.5 times 4 times 10 Newton. B. Period t is equals to time for number of acceleration over number of oscillation. Therefore, period t is equal to 60 over 50, which will give us 1.2 seconds. Question 4. A. An object weighs 10 Newton in air and 7.0 Newton in water. What is the weight when immersed in a liquid of relative density 1.5? B. A block of material of volume 20 cm cube and density 2.5 g gram cm cube per cm cube is immersed for a spring balance with the half of the volume of the book immersed in water. What is the reading of the spring balance? Density of water equals to 1.0 gram per cm cube. Solution. A. Let the apparent weight equals to be equals to x. Therefore, the relative density is equal to updraft of the liquid over updraft water. We have that the relative density is 1.5, which is equals to updraft of the liquid, which is 10 minus the apparent weight, x, over updraft of the water, which is 10 minus 7. Then we have that if we cross multiply, we have that 10 minus s is equals to 1.5 times 10 minus 7. 10 minus s is equals to 4.5. Therefore, x, making s the subject of the formula, we have that minus s is equals to 4.5 minus 10, which will give us minus 5.50 Newton. Then when the minus cancel it both sides, we have that s is equals to 5.5 Newton. That's the weight, apparent weight. Solution B. Apparent weight equals to weight in air equals to updraft. Updraft is equals to volume of water displaced times density of water. Therefore, the apparent weight is equals to 20 times 2.5 minus half times 20 times 1, which is equals to 50 minus 10 which now gives us 40 grams. Density. Density is mass per unit volume. The density of cold air has high density than that of hot air. Density is equal to mass over volume, which is equal to gram per cm cube or kilogram per meters cube. Density with temperature, which means inverse ratio with temperature. Volume of cylinder is pi r squared h. Volume of a sphere is equal to 3 over 4 pi r cube. Volume of a square is length times width times height. Irregular shapes. Increase in volume of the liquid is equal to the volume of the object. Density is equal to mass over volume. The volume of the cylinder is pi r squared L2 minus L1. That is L2 is the final level, while L1 is the initial level. Then, substituting this into the density, we have that density equals to m, that is the mass, over the volume, which is pi r squared in bracket L2 minus L1. Then, cross multiplying, we have that density pi r squared in bracket L2, that is the final level minus the initial level, is equals to mass m. Then crossing the density, leaving the ones in brackets behind, we have that L2 minus L1 is equal to mass over density pi r squared. Therefore, the L2, which is the final level, is now equal to, in bracket, mass over density pi r squared plus close bracket L1. Irregular solids. The mass of an irregular solid body can be obtained by direct weighing. The volume is found by immersing the body in water, provided it will not sink and that they are not soluble in water. The volume of the water displaced will be equal to the volume of the solid. A measuring cylinder or an overflow may be used in determining the volume of the liquid displaced. Question 5. Using in figure 1.44, using the diagram above, calculate the moment of force of 10 Newton above point P. In figure 1.45, the body P shown in the diagram above is equilibrium. If the mass of the body is 10 kg, calculate the tension T in the string, taking the acceleration due to gravity equal to 10 meters per second. Solution. Looking at figure 1.6, the resolved perpendicular distance of P from O is equal to OX. OX over OP is equal to cos that, according to the law of trigonometry. We have that OS is equal to OP cos 30 degrees. We have that moment is now equals to 10 times 12 cos 30, which will give us 120 times cos 30 is square root of 3 over 2, which is now equals to 60 square root of 3. Therefore, the moment will now be equal to 103.92 Newton meter. Solution B. Figure 1.47 example